In recent months, one of the most unusual and intriguing waves of rumors in years has begun to form around Tesla. While the entire world is focused on the development of artificial intelligence, Optimus humanoid robots, cybercab autonomous taxis, and massive computing centers for AI training, some analysts are increasingly paying attention to another direction that until recently seemed like pure science fiction. This refers to the potential development of Tesla's first flying vehicle. It all began after Elon Musk, in one of his conversations with Joe Rogan, once again touched on the topic of flying transport. Formally, no official announcement about the launch of such a project has been made. However, Tesla investors have long been familiar with Musk's pattern. Very often he first casually mentions a technology, and then a few years later it turns out that internal work on that exact direction has already been underway for a long time. This was the case with Optimus robots. This was the case with autonomous driving. This was the case with cybercab. That is why even a small hint from Musk generated enormous interest among analysts, engineers, and journalists. In recent weeks, several industry observers have noticed an interesting pattern. Tesla is actively developing three directions simultaneously. The first is autonomous driving. The second is artificial intelligence. The third is new transportation platforms, including the robovan. And the more experts analyze these projects, the more often a theory emerges that in the future, they may all merge into a single device. Some analysts even suggest that the robovan itself could become the foundation for Tesla's first flying vehicle. To begin with, it is worth recalling what the robovan actually is. When Tesla first presented this concept, many viewers were surprised by its size and unusual design. Unlike the company's familiar vehicles, the robovan looks more like something from a science fiction future. It is a large autonomous electric vehicle designed to transport a large number of passengers or cargo. Tesla has stated that such a machine could be used as next-generation public transport, a corporate shuttle, a tourist transport system, a logistics platform, or even a mobile office. The main idea is that the absence of a driver allows for a complete rethinking of interior space. But it is precisely the size of the robovan that has unexpectedly become the main argument for supporters of the flying version theory. The fact is that creating a fully functional flying car comes with a huge number of engineering constraints. Small flying machines face serious limitations in energy capacity, stability, and safety. A larger body, however, allows for the integration of far more batteries, computing systems, redundant control systems, and propulsion units. Some specialists believe that if Tesla truly intends to develop a flying vehicle, the most logical starting point would be the robovan platform. Interestingly, a similar strategy is now being used by many companies working in the field of aerial mobility. Instead of building flying sports cars, they are focusing on large autonomous vehicles designed to transport people along predefined routes. Such projects are being developed by American, European, and Chinese companies. Some of them are already testing vertical takeoff and landing vehicles. However, none has yet achieved large-scale commercial success. This is where Tesla could gain a significant advantage. The company already has extensive experience in battery development. Tesla operates its own battery manufacturing plants, its own energy management systems, and has vast experience optimizing vehicle weight. In addition, Tesla possesses one of the most powerful artificial intelligence infrastructures among automotive companies in the world. Regarding autonomous driving, the amount of data collected by Tesla vehicles around the world already amounts to billions of kilometers of real-world driving experience. Some experts suggest that autonomy itself could become the key to the emergence of Tesla's flying transport. Looking closely at the development of the industry, it becomes clear that the main obstacle is not so much flight itself, but control safety. Humans are capable of making mistakes. In the air, the cost of an error is significantly higher than on the road. That is why many specialists believe that the first mass-market flying vehicles will be fully autonomous from the very beginning. Imagine a scenario 10 years from now. You request a vehicle through a Tesla app in the same way people order a taxi today. Within minutes, a next-generation autonomous robovan arrives at a dedicated platform. After passengers board, The system automatically checks weather conditions, air traffic, battery status, and the route. Then the vehicle smoothly lifts into the air and travels to its destination without a pilot. All control is handled by Tesla's next-generation artificial intelligence. Today, such a scenario sounds like science fiction. But just 10 years ago, the idea of a car capable of driving itself through a city without a driver sounded equally unrealistic. Today, millions of people are witnessing the development of this technology in real time. However, between a concept and a real product, there is still a huge gap. That is why analysts identify a whole list of challenges Tesla would need to solve. The first challenge is energy. Even the most advanced batteries have a significantly lower energy density compared to aviation fuel. Flight requires an enormous amount of energy, especially when it comes to vertical takeoff. This is why many engineers consider batteries to be the main limitation of the entire industry. The second challenge is safety. If a conventional car can pull over to the side of the road in case of a malfunction, airborne transport does not have that option. This means highly redundant systems will be required. Each critical component may need multiple independent backups, from motors to computing modules. The third challenge is regulation, which many experts consider the most difficult factor. Even if Tesla were to demonstrate a fully working prototype tomorrow, it would not immediately reach the market. Regulators in the United States, Europe, and Asia would require years of testing and safety validation. A new category of transport would require new certification standards, new operational rules, and entirely new infrastructure. And this is where things become especially interesting. Some analysts believe that artificial intelligence itself could accelerate this process. The more reliable autonomous systems become, the easier it will be to convince regulators of their safety. Given the pace of AI development in recent years, this situation may evolve much faster than many expect. The question of cost is equally important. If Tesla were to actually build a flying robovan, how much would it cost? Expert estimates vary widely. Some suggest prices above $1 million per unit in the early stages. Others believe that thanks to mass production, Tesla could eventually reduce the cost to a few $100,000. But almost all analysts agree on one point. Early versions would not be aimed at private consumers, but at commercial transport services. This is where a potential revolution begins. Imagine a future megacity. Millions of people spend hours every day stuck in traffic. Roads are congested. Building new highways becomes increasingly expensive and difficult. In such a situation, the use of airspace looks like an extremely attractive solution. Instead of constructing thousands of kilometers of roads, cities could gain an entirely new transportation layer above existing infrastructure. Some futurists call such a system a three-dimensional transport network. Unlike traditional roads where vehicles move in two dimensions, aerial transport gains the ability to use the third dimension. This fundamentally changes the principles of logistics and human mobility. If Tesla turns out to be the first company capable of implementing such a concept at a mass scale, the consequences for the industry would be enormous. Competitors would face an extremely difficult choice. Either urgently invest billions of dollars into developing similar solutions, or risk losing a significant share of the future market. Companies from China are paying particularly close attention to the situation. Chinese manufacturers are already heavily investing in air mobility technologies. Several Chinese companies are testing electric vertical takeoff and landing aircraft. Some analysts believe that China and Tesla could become the main participants in a new technological race over the coming decades. But looking even further ahead, the consequences could extend far beyond the transport sector. The emergence of mass aerial transport could transform city architecture, real estate markets, tourism, logistics, construction, and even the structure of employment. Districts that today are considered remote from city centers could suddenly become only a few minutes of flight away from business districts. Some investment banks are already modeling such scenarios. According to several forecasts, in the event of the emergence of affordable autonomous aerial transport, the value of certain categories of real estate could change in highly unexpected ways, as people would be able to live significantly farther from their workplaces while maintaining minimal commute times. This is precisely why so much discussion is currently emerging around Tesla's potential flying project. there is still no official confirmation of such a product. There is no presentation, no prototype, no concrete specifications. But Tesla's history shows that many of the company's boldest ideas were initially perceived as science fiction and then gradually turned into real products. This is why every new hint from Elon Musk triggers such a strong reaction from analysts around the world. And if one day a flying robovan truly appears on stage alongside Cybercab and Optimus, that moment could become one of the most important events in the history of modern transportation, because it would no longer be just about a new vehicle, but about the beginning of an era in which humanity gains the ability to move through the air as easily as it currently orders a taxi via a smartphone. As analysts delve deeper into the topic of a potential flying robovan, more and more questions arise about how exactly Tesla could implement such a project in practice. Many experts point to one interesting pattern. Almost all major Elon Musk projects initially seemed impossible. When SpaceX spoke about reusable rockets, most specialists considered it too difficult and economically unfeasible. When Tesla announced its intention to make electric vehicles mainstream, the automotive industry met the idea with skepticism. When the company began talking about Optimus robots, many analysts called it a distraction from its core business. Yet today, reusable rockets have become the standard for SpaceX. Tesla sells millions of electric vehicles, and Optimus is gradually moving beyond the laboratory stage. This is why some investors are closely watching for any indirect signs that a new direction may be forming inside Tesla. In recent years, the company has significantly strengthened its capabilities in artificial intelligence, autonomous control, and energy systems. For a conventional car, this already provides a major advantage. But if the focus shifts to flying transport, the importance of these technologies increases dramatically. Particularly interesting is the question of computing power. Imagine a future autonomous robovan moving not on roads, but in the air. It would need to analyze its surrounding environment in all directions simultaneously, track weather conditions, monitor dozens of other aerial vehicles, calculate routes in real time, oversee its own system health, and make decisions within fractions of a second. All of this would require an extraordinarily advanced computing platform. This is where many analysts draw a parallel between the development of Tesla's AI and the potential emergence of aerial transport. Some experts believe that the company's current investments in supercomputers and neural network training may have a much broader purpose than simply improving autonomous cars. The smarter artificial intelligence becomes, the more transportation-related challenges it is capable of solving. There is also another interesting theory. According to it, the first flying robovan may not be just a vehicle, but part of a larger ecosystem. Tesla has long aimed to build not isolated products but interconnected systems. Cars are linked to charging infrastructure. Home batteries are connected to solar panels. Optimus robots may eventually operate within Tesla's industrial network. Therefore, some futurists suggest that future aerial transport could also become part of a unified network. Imagine a future city where rooftops are equipped with automated landing platforms. Artificial intelligence distributes aerial routes in such a way as to minimize the risk of trajectory intersections. A robovan arrives at a platform, automatically boards passengers, performs diagnostics, and departs. All processes are controlled by a central intelligence system that continuously analyzes millions of parameters. Such infrastructure may sound like science fiction, but it is worth remembering that only a few years ago, the idea of a fully driverless taxi without a steering wheel or pedals was also considered unrealistic. Today, Tesla is already demonstrating Cybercab, which moves precisely in that direction. There is another reason why analysts associate the potential flying project specifically with the robovan. This format is better suited for commercial operations. A personal flying car looks impressive in advertisements, but its economic model remains questionable. A vehicle capable of transporting multiple passengers is a different matter entirely. The more people on board, the easier it becomes to distribute the cost of the trip among them. Some specialists believe that the first large-scale aerial routes may resemble modern bus lines. Instead of flying to any point in a city on an individual request basis, the robovan could operate between pre-established transport hubs. This would significantly improve safety and simplify regulatory oversight. However, even if the technology is ready, Tesla would likely face serious resistance. Many aviation experts already warn that large-scale use of airspace could introduce new challenges. One example is noise pollution. Even relatively quiet electric propulsion systems can create discomfort for urban residents. If thousands of vehicles begin moving simultaneously over a megacity, noise would become a critical issue. Another major challenge is airspace safety. Today, airplanes and helicopters operate along strictly controlled routes. If the number of aerial vehicles increases by tens or hundreds of times, entirely new traffic management systems would be required. Some experts believe that without powerful artificial intelligence, such a system would be impossible to operate at all. This is why there is a growing belief that the future of aerial mobility is directly tied to the development of AI. Without intelligent coordination systems, it would not be possible to manage the movement of millions of autonomous vehicles. And this brings the discussion back to Tesla, which is widely considered one of the most advanced companies in applied artificial intelligence today. It is also interesting to consider how such a technology could reshape the logistics economy. Today, cargo delivery often takes hours or even days. A flying robo-van could drastically reduce this time, especially in densely populated urban areas. Some logistics companies are already modeling scenarios in which goods are delivered almost instantly via air routes. In this case, Tesla would not only compete with automotive manufacturers, but also with global logistics giants. The potential market becomes significantly larger than it appears at first glance, as it is not simply about selling vehicles, but about building an entirely new infrastructure for transporting people and goods. Another important aspect is operating cost. Many critics of aerial mobility argue that such systems will never become mainstream due to high expenses. However, Tesla supporters point out that similar arguments were once made about electric vehicles. When the first Teslas appeared, many experts claimed that electric cars would remain expensive toys for wealthy buyers. Over time, that perception changed dramatically. If Tesla manages to achieve significant breakthroughs in next-generation battery technology, the cost of aerial transport could decline much faster than skeptics expect. Some analysts even suggest that in the long term, the price of an air taxi ride could approach that of a regular taxi. But there is another factor that makes this story particularly interesting: its impact on Tesla's stock. Financial markets have always reacted strongly to breakthrough technologies. If the company ever officially confirms a program for aerial transport, investor reaction could be extremely volatile, especially if Tesla demonstrates real prototypes or operational tests. In recent years, investors have increasingly come to view Tesla not as an automotive company, but as a future technology platform. Robotics, artificial intelligence, energy systems, and autonomous control are already reshaping Wall Street's perception of Tesla's business model. Flying transport could become another key element in this evolving narrative. At the same time, many analysts warn against excessive optimism. History shows numerous examples of promising concepts that ultimately faced unexpected obstacles. Even if Tesla is indeed working on such a project, the path to mass adoption could take years or even a decade. But it is precisely here that Elon Musk's character becomes most visible. Almost every major project by the entrepreneur has been designed with a long-term perspective. SpaceX took years to prove the viability of reusable rockets. Tesla spent decades building out the infrastructure for electric vehicles. That is why many experts believe that if a program for developing aerial transport truly exists within the company, its results may not appear immediately. Nevertheless, the number of discussions around this topic continues to grow. More and more engineers, investors, and industry analysts are beginning to consider the scenario of a flying robovan as a potentially plausible direction for Tesla's future development. And although at present we are mostly dealing with rumors, theories, and speculation, the history of the technology industry shows that such rumors sometimes become the first signals of future revolutions. Perhaps in a few years we will look back on today's discussions in the same way we now recall the early conversations about autonomous vehicles or humanoid robots. At the time, those ideas seemed overly ambitious. Today, they are gradually becoming reality. If Tesla is indeed preparing something of this nature, the emergence of a flying robovan could become one of the most significant technological events of the next decade. But there is another scenario that some Silicon Valley analysts and urban infrastructure futurists are beginning to discuss today. According to this theory, Tesla may not actually be trying to build a traditional flying car in the way most people imagine it. Instead, the company could be aiming to create an entirely new category of transportation that sits between a car, a drone, and public transit. And this is where the robovan concept becomes especially interesting. The issue is that many flying car projects in recent years face the same fundamental problem. They attempt to replace a conventional car one-to-one. In other words, a single passenger or a small group of people is given a dedicated aerial vehicle. However, economists have long warned that such a model could end up being too expensive and inefficient. It makes far more sense to use larger capacity platforms capable of transporting multiple people at once. That is why the robovan keeps appearing in these discussions. Some experts suggest that a future aerial robovan could function as a kind of autonomous minibus of the future. Imagine a vehicle capable of transporting 10 to 20 passengers simultaneously. Such a system could serve airports, business districts, tourist routes, and large metropolitan areas. At the same time, the absence of a pilot would significantly reduce operational costs. There is another reason why many consider such a project plausible. Tesla is already actively working on its own software for managing autonomous transport systems. In effect, the company is gradually transforming itself from a vehicle manufacturer into a developer of an intelligent transportation ecosystem. And if one looks at the situation from this perspective, it becomes clear that the next logical step may involve expanding mobility from roads into airspace. Particularly interesting is the question of how such a system might interact with Optimus robots. Some futurists paint a rather unusual picture of the future. Tesla robots could handle the maintenance of aerial terminals, assist passengers during boarding, monitor the technical condition of vehicles, manage cargo loading, and even participate in repairs. In such a scenario, the entire ecosystem would operate in a largely autonomous manner, with minimal human involvement. Many analysts believe that this kind of integration of different technologies could become Tesla's main competitive advantage. While other companies are developing separate products, Tesla is gradually building a unified system where artificial intelligence, transportation, energy, and robotics all reinforce one another. If such a scenario begins to materialize, the consequences for the global market would be enormous. Automotive manufacturers would be forced to accelerate their own autonomous transport programs. The aviation industry would face a new class of competitors. Logistics companies would need to integrate aerial transport into existing supply chains. And cities would begin to consider infrastructure that, only a few years ago, would have seemed like science fiction. That is why, despite the lack of official confirmation of a flying robovan, interest in the topic continues to grow rapidly. Every new comment from Elon Musk, every new Tesla patent filing, every new breakthrough in artificial intelligence immediately triggers renewed discussion. As autonomous driving, battery technology, and AI continue to advance, the idea that Tesla could one day reveal a prototype flying robovan becomes increasingly less implausible. For now, it remains only a hypothesis. But if Tesla's history has taught investors, engineers, and analysts anything, it is that Elon Musk's most improbable ideas sometimes turn out to be much closer to reality than they initially appear. It is entirely possible that right now, behind the closed doors of the company's engineering centers, research is already underway into technologies that could one day transform the transportation industry just as profoundly as electric vehicles transformed it in the previous decade. If such a moment truly arrives, and Tesla presents the world's first flying robovan, it would no longer be just another new product from the company. It could mark the beginning of a new era of mobility, in which distances between cities, airports, and business centers shrink to mere minutes, and the conventional understanding of transportation begins to rapidly fade into the past. In that case, today's rumors, which many dismiss as enthusiast speculation, may turn out to be the earliest signs of one of the largest technological revolutions of the 21st century.